presenting on the chemical process industry. So our presentation outline goes like we look at the history of the chemical industry, the modern chemical industry. We look at developments in the chemical process industry. We look at some industrial production operations and processes. We look at how a chemical process is carried out and then some typical issues in the chemical industry. We will also consider various aspects of the chemical process industry. We look at various industrial gases. We consider energy conservation in chemical process industries, some chemical processes. We look at chemical process flow diagrams. So we talk about the history of the chemical industry. The chemical industry were known by the ancient Egyptians. It originated from ancient Egypt, India, Greek. The ancient Egyptians used to make soap from soda, that's sodium carbonate, and then they would add fat to it. This soup was used to wash corpses or dead bodies in order to prevent them from decaying earlier or to keep them for a longer period. They also made cement from volcanic ash, rocks, and caustic soda, that's sodium hydroxide. The ancient Indians, that's the Mayan Indians, also were known to use latest balls in their games and in their clothing. When we talk about the modern chemical industry, it began in UK around 1750 to 1800. The methods that were used, some of the methods that were used or developed was in England. In 1749, there was the lead chamber method, which was used in the production of sulfuric acid. It was sponsored by industrial revolution because a lot of chemicals were demanded by chemical industries, and it led to the development of the modern chemical industry. They made soap from alkali and animal fats. They made cotton bleach, and then they made glass from sand, that's silicate oxide and sodium. So when you look at the graph down here, you can see that there has been a lot of changes in the chemical industry. This is a graph of the chemical industry in the US. So from the year 1900 to 1970, there has been a rise in chemical demand or demand for chemicals from industries, leading to the development of the modern chemical industry. When you look at caustic soda, there has been a rise from 1900s to the 1970s, and then ammonia and sulfuric acid is in high demand. Looking at the graphs, so when you look at the graph, there are a lot of tons of sulfuric acid that is produced each year in the US, and this led to the revolution of the industrial revolution of the chemical industry to become modern. Then we talk about the development of the chemical industry. The chemical industry dates back to prehistoric times, when first man attempted to control and modify his environment. So when we talk about the developments in the chemical industry, we talk about the pre-scientific chemical industry era and the scientific chemical industry era. The pre-scientific chemical industry era dates back to the ancient Egyptians when there was no machines and stuff for making chemicals. And then we talk about the scientific chemical industrial era. In the scientific chemical industrial era, there has been a lot of development. That's the integration of big data, the use of programming in chemical processes, automation and robotics, material design and discovery, green chemistry, precision medicine, accelerated drug discovery. So look at the bottom on the right left, you see a chemical industry. This is a modern chemical industry with some equipment. We'll move on to industrial production, some basic concepts in process operations. So when you look at this picture, you see a scientist with some apparatuses in front of him. So when we talk about production systems, they are the systems used in chemical industry. They do not work in isolation. It involves three chains. We have the people's chain, the process chain, and the product chain. So the people's chain are those who make the chemical system work. So when you look at the diagram here, there's a scientist. He's part of the people's chain. He's a chemical engineer and he's working on a process. So the apparatuses and the process reactions all constitute the process chain. And then at the end of the day, he's trying to find out something. He's using the distillation method to find out distilled water. So the distilled water becomes part of the product chain. So those are the process operations in the chemical industry. We move on to how the chemical process is carried out. First of all, before we undertake a chemical process, we consider it, how is it going to be like? Is it going to be a physical change or a chemical change? How is it going to be carried out? The thermodynamics of the chemical process, the ultimate limit of conversion, how the things are going to be done, how fast is it going to be carried out, the rate of the reaction kinetics, the time required for the completion of the reaction. So those are some of the key questions in a chemical process. When we talk about issues in the chemical industry, as at now, some of the issues in the chemical industry has gone a lot. So we consider some of the plastics issues, our lubricant issues, the polymers, the fuels, the surfactants, fertilizers and pesticides, solvents, inks and dyes. These are typical issues in chemical industries. How we handle these pollutants and the whole lot are some of the issues in the chemical industry. So we consider various aspects of the chemical industry. The chemical industry has a lot of sectors. So we have petrochemical aspects, the agrochemicals, the pharmaceuticals, polymers, fertilizers, refining, and specialty chemicals. We talk briefly about some of these aspects. There are many more aspects. So when we talk about the petrochemicals, it concerns itself with the production of chemicals from petroleum and natural gas. Then we look at agrochemicals, the manufacture of fertilizer, pesticides, and other agricultural chemicals that are used in farming. We look at pharmaceuticals, production of medicines and pharmaceutical products. We look at polymers, the manufacture of plastics, fibers, and other polymer materials. When we talk about fertilizers, those are the stuff that are used in agriculture to help boost production and also increase the amount of goods that are produced from agricultural processes. We talk about specialty chemicals, the manufacture of paints, coatings, the paints that are used on our walls, our coatings, the adhesives, the super glue we use to do our shoes, and a whole lot. Then we consider some of the industrial gases that are used in the chemical industry. So these gases are usually required in large quantities, and we have some examples of them. We have hydrogen, nitrogen, oxygen, carbon dioxide, acetylene, ethylene, and helium. These are a few of the gases that are used in the chemical industry to help chemical processes to run. And then we talk about energy conservation in chemical process industries. When we talk about energy conservation in chemical process industries, we look at how we make energy, we make good use or efficient use of energy, how we do our energy management, how we adopt smart manufacturing in order to conserve energy, we improve material and process efficiency, we combine various energy sources, that's the utilization of combined heat and power. Then we look at industrial electrification of process heating, how we use space heating, how we use hydrogen in our production, and development of electrified processes that lead to energy conservation in a sustainable environment. We consider low carbon fuels, feedstocks, and energy, how we are able to utilize the development of biofuel infrastructure and prevent a lot of carbon from going into the atmosphere. We look at carbon capture, utilization, and storage, that's CCUS. We look at how we can capture carbon from the atmosphere in order to prevent a lot of pollution or pollutant from escaping into the atmosphere. There are some of the energy conservation processes in the chemical industry. Then we talk about some chemical processes. So in the industry, a lot of processes that goes on. We talk about reaction engineering, separation processes, heat transfer, mass transfer, greenhouse gases, combustion and incineration. When we talk about reaction engineering, it's the design and optimization of reactions, how reactions are designed to be implemented. We look at separation processes like distillation and crystallization. So distillation is the distillation of like crude oil in order to get oil and gas or petroleum or in order to get methane or something. And then we look at crystallization of maybe seawater to get salt. We look at heat transfer, the management of heat energy in chemical process. We look at mass transfer, the transfer of mass between phases in chemical processes. We look at greenhouse gases, the combustion of reactions. That's the burning of substances in the presence of oxygen. We look at incineration. That's the way of taking care of waste in order to prevent our environment from being polluted using a heat combustion system, that's incineration. Then we talk about chemical process flow diagrams. A process flow diagram, that's PFD, is a diagram commonly used in chemical and process engineering to indicate the general flow of plant processes and equipment. So when we look at the diagram here, these ones are developed by softwares like Aspen and Cocoa. They are chemical process flow diagrams. They show how a chemical process or plant runs. So when you look at this diagram, it's a flow diagram of a typical amine treating process used in the industrial plant. So when you go to an amine treating plant, when they show you this diagram, you understand that this is how the plant runs. From the maker porter, you put in maker porter, and then from one distillation plant or cylinder to the other, this is what happens in the system. So that's the use of a chemical process flow diagrams. So we have a presentation here. Thank you.